So, hello everyone, welcome you all for the PCD of Code Forces round Div 2 968, if I'm not wrong. So, let's start with the discussion. This is the first question, turtle and good strings. The question reads like this. Turtle thinks a string S is a good string if there exists a sequence of strings T1, T2, Tk, where k is an arbitrary integer, such that k is greater than equals to 2, and S is equals to T1 plus T2 plus up till Tk, where plus represents the concatenation operation. For example, ABC is equal to A plus BC. For all I lesser than j, the first character of Ti is not equal to the last character of Tj. This is the condition. So Turtle is given a string S consisting of lowercase Latin letters. Please tell him whether the string S is a good string or not. So first of all, let's understand what the question wants to say. According to the question, you are given a string S. You are given a string S. So let's suppose string S is A, B, C, D. This is your string S. And you have to divide this string into some multiple substrings. Like you have to divide it, let's suppose you divided it into 3 parts. You have to divide it in minimum 2 parts because it is mentioned in the question that a value of k is greater than equal to 2. So let's suppose you divide it into 3 parts, and those 3 parts are, one part is AB, the second part is C, and the third part is D. So the question is that when you add these 3 parts, so basically you should be able to form a string. So that's the reason we are telling that we are dividing the string into parts. Once we do so, the question says that if this is the first part, this is the second part, this is the third part. So for any part I that comes before j, the first character of Ti should not be equal to the last character of Tj. What does we mean by that? By this we mean that if this is a part that is coming before these 2 parts, so the first character of this part should not be equal to the last character of any other part. So you can see the first character of this part is not last character of any of these parts. Similarly, the first character of this part is not equal to the last character of any of the parts that occur after it. So this is a valid break. This means that, yeah, we can break the strings into these substrings. So in this case, we will return answer yes. You simply need to return yes or no, whether you can break the string that follows this particular condition or not. So this is actually what question means. Do anyone have any doubt in the question? Do anyone have doubt in the question? What question wants to say? Yes. What is your doubt? Wait a minute. You are allowed to unmute. You can say, Risha.
Sir, basically we have to divide, or we have given the divisions that we have to divide it. The string is divided into these parts.
Yeah, it's given that the okay, you can unmute, you can mute yourself. It's given that you are dividing string into these parts, T1, T2, Tk. You are dividing it into k parts, so that when you add these k parts, it forms the string S again. So basically, what you are doing, you are dividing it. You are having a string S, and you are dividing it into parts. Now, this is the first part. This is the second part. So when you add these 3 parts, you will form the string S again. So over here, the value of T1 is AB, the value of T2 is C, the value of T3 is D. So you are not given these parts. You can choose it by your own.
Okay, sir.
Okay. So anyone else having doubt in the question? Or kindly mute yourself if anyone is unmuted. No, right? So how we can solve this question now? So just imagine one thing. What you're doing. You're dividing strings into parts. You're dividing strings into parts, and what you are telling is that okay, if I have a part, if I have one part over here, so any part that comes after this particular part, any part, let's suppose this is Ti and we have another part Tj. So the question demands is that the first character of this Ti should not be equal to the last character of this Tj. So just say me one thing. So it does not matter how many parts you are dividing it into. If you are dividing it into any number of parts, there will be a one of the part will be the first part of the string of the division, and one will be the last part. So if the first character of the string is equal to the last character of the string, is it ever possible to divide the string into at least two parts? Just imagine, it does not matter how many parts you have divided it into. If the first character of the string is equal to the last character of the string, so you will have that, okay, you have one part such that the first character of this part is equal to the last character of some part that is coming after this part. That is, if this is T1 and this is Tk, so you have the first character of T1 equal to the last character of Tk, and this is something that is not allowed in the question, isn't it? So if the first character is equal to the last character, so we know that the answer will always be no. Do anyone have any doubt in this? If first character is equal to last character, the answer will always be no. And if first character is not equal to last character, so just imagine what you can do. You can always divide this string into two parts because you want to divide it into at least two parts. Question says you that divide it into at least two parts. So what you do is you always divide it into two parts. And whenever you do so, the condition will be satisfied that the first character of this part does not match the last character of any other part that is coming after this. Since you have divided it into only into two parts, so these are the only two parts you have. So the logic was that if the first character is equal to the last character, the answer will be no. Else the answer will always be yes, as you can always divide the string into two parts, such that this is one part and this is the other part. Do anyone have any doubt in the logic? Is it clear for everyone? Yes. Okay. So jumping on to the implementation. So first of all, took the length of the string as input, then took string as input. And if the first character is equal to the last character, then printing no, else printing yes. So a very simple code for the first one. So let's jump on to the second question. So the name of the question is Turtle and Piggy are playing a game too. So Turtle and Piggy are playing a game on a sequence. They are given a sequence A1, A2 up till AN, and Turtle goes first. Turtle and Piggy alternate in turns. So Turtle does the first turn, Piggy does the second, Turtle does the third, etc. So Turtle is starting with the turn. Okay. The game follows as such. If you are left out with only m equals to 1, that is the current length of the sequence is m. If m equals to 1, the game will end. That is, if you are left out with only one element, game will end over here. If the game does not end and it is Turtle's turn, then Turtle must choose an integer I such that I lies from 1 to m minus 1, and he will set ai to max of ai and ai plus 1 and remove ai plus 1 from the sequence. So what he will do, he will choose any integer I, take max of ai and its adjacent element and remove ai plus 1. Okay. And if it is Piggy's turn, so what it will do is the Piggy must choose an integer I such that I lies from 1 to m minus 1, and he will set ai to minimum of ai and ai plus 1 and will remove ai plus 1. Okay. So Turtle wants to maximize the value of ai in the end, while Piggy wants to minimize the value of ai in the end. So you need to find the value of a1 if in the end if both the players play optimally. So you know that at the end you will be left out with only one value. Turtle wants to maximize that left out value and Piggy wants to minimize that left out value. And if both are playing optimally, so the question is that what is the value that will be left out at the end? So this is the question. So if I just take one example, if I take this example 31223, 31223. So first of all, the turn is of First of all, it is Turtle's turn. Turtle is starting and Turtle wants to maximize the leftover value. Maximize the leftover value. And Piggy, what do Piggy want? Piggy want to minimize the leftover value. Okay. So first of all, we have Turtle's turn. So let's suppose Turtle do something like this. He is playing optimally. So Turtle choose this integer, set this as the maximum of this and this. So set this as 2 and removes this. Okay. Now it's Piggy turn. What Piggy do is Piggy choose this integer, let's suppose, choose minimum of these two, and set this as the minimum value and remove this AI plus 1. Now it's again Turtle's turn. So let's suppose Turtle choose this. So Turtle choose this and sorry, let's suppose wait a minute. Yeah. So let's suppose Turtle choose this integer. So he choose the maximum of this and this, which is 2 again. So it will keep as 2 and delete this. And now what does Piggy do? Piggy do this, choose minimum of 2 comma 3, which is 2, and removes 3. So the leftover value at the end is 2, and this is the maximum possible value that you can obtain. So the question is that what is the if both players are playing optimally, so what is the leftover value? What will be the leftover value in the array? Is the question clear with everyone, or if anyone is having any doubt with the question, kindly let me know. Do anyone have doubt in the question? No. So if question is clear, how we can solve this? So this was actually an easy problem if you understand that how actually things are working. Just observe one thing. What does Turtle want? Turtle want to maximize the end value. So what will Turtle do? If it wants to maximize the end value, what will Turtle do? Turtle will remove the minimum value from the sequence. Do you agree? Do you agree? Similarly, what does Piggy want? Piggy wants to minimize the value, minimize the end value. So can I say that Piggy will remove the maximum value from the sequence? Can I say this? Do anyone have doubt in this? Just tell me. Do anyone have doubt in this? No. If this is clear, now the things are very easy. Let me take an example and then we can explain. Let me take this particular example. So you have 10 numbers. So let's suppose I simply short these values. So if I shorting these values will be 2, 2, 2, 5, 5, 7, 7, 9, 10, and 10. So now what will first of all Turtle do? It is first of all the turn is of Turtle. First of all, it's Turtle's turn, right? So what will Turtle do? It will remove the minimum value from the array. So it will remove 2. It will remove 2. And now it is Piggy's turn. So Piggy will remove the maximum element. Then again, Turtle will remove minimum. Piggy will remove maximum. Turtle will remove minimum. Piggy will remove maximum. Turtle will remove minimum. Piggy will remove maximum. Turtle will remove minimum. And now you are left out with only one value. So the final value that will be obtained in the array will be 7. And if you observe, this is nothing but the median. This is nothing but the value of n by 2th index. The value present at n by 2th index. Similarly, let's suppose over here the array length was even. Similarly, let's suppose the array length was odd. Let's suppose the length was 5. So you would have had 5 elements. So Turtle would have removed the minimum, Piggy maximum, Turtle minimum, Piggy maximum, and you will be left out with this value. This is again the value that is present at n by 2th index. So the question was that simply sort the array and return the value present at n by 2th index of the array. This was actually the logic to this question. Yeah, wait a minute. Yes, you are allowed to speak now.
Hi, sir. Actually, I also think about this problem in the same way that the turtle will delete the minimum element from the sequence so that only greater elements or equal elements are left in the series, and Piggy will do just do the opposite of what turtle will do.
Yes.
But do
Excuse
you
me, sir.
don't?
Pardon, sir. Sir, can you please just repeat last 2 minutes? I was not able to because of internet.
Let him complete his question. Yeah, Tushar.
Okay, sir. Okay.
But do you don't think that the order should matter in this case?
No, order will
Uh,
not matter. Order will not matter. Let me explain you with one more example.
yes.
Let's suppose you have 3, 1, 2, 2, 3. The one who was asking for last 2 minutes can listen over here. 3, 1, 2, 2, 3. So when you sort this array, you will have array something like this, isn't it?
Yes, sir.
So now I am telling you that turtle wants to remove 1. So you can
Yes.
observe that he can always remove 1. Because if we choose AI as this, he can always he can always set this as 2, that is max of 1, 2 and remove this 2. Okay.
Yes, sir.
So this 2 is removed. So this 1 is removed actually. You have 2 and this 1 is removed.
Yes.
1 is
Yes.
removed. Now Piggy
Exactly.
wants to remove 3. So he can always
Yes,
remove
sir.
3. Because he can choose this index, set this as the minimum of 3, 2, which is 2, and
Yes, sir.
delete this 2. So he has removed 1, 3. Isn't
Yes.
it?
Yes.
Now again, now Piggy wants to, now Turtle wants to remove this 2. So he can always choose this as the index and he can just take max of 2, 2, which is 2 again, and he can remove this 2. So he can remove this 2. So he is
Yes.
able to remove a 2. Now Piggy wants to remove 3. So what he will do? He will choose this particular index, take minimum of 2,
Yes, sir.
3, which is again 2, and
2.
he will remove this. So he is able to remove 3 and the end value that is remained is 2. So the order does not matter, the sequence is always possible. So the logic is that simply sort the array and take the median.
Oh, yes, sir. I
Sir,
understood by your test case, but how we can prove this basically?
No, it's not
Actually,
required to prove.
I
No, like,
was I was not able to prove this. As I said, I am able to generate the logic, but I am not able to transform this into the code. For that, I have to sort it in this.
like it is always possible. Na? Like what you want. First of all, what you want? You want to remove the maximum element from the array. If you are a PG, you want to remove the maximum element of the array, isn't it?
Yes, sir.
Now
Yes,
you
sir.
can always remove it. Just assume y. Wherever the maximum element is present, it does not matter. You will always be able to remove it. Just tell me the position where you feel you will not be able to remove it if the maximum element is present in.
Uh, yes, sir. Because the adjacent elements will definitely be lesser than its.
Because if let's
So
suppose
Piggy will
adjacent
cut. Yes,
element
sir.
is present over here, so you will
Yes.
choose index over here. And since you are
Yes, sir.
taking minimum of these two and keeping the minimum value, storing the minimum value at this position and removing the maximum one, so you will be able to remove the maximum element, isn't it?
Yes, sir.
Wherever
Yes, sir.
the
Yes, sir. Sure,
maximum
sir.
element is present, you will always be able to remove it. So that is the logic actually.
Yes, sir. Yes. Now I understood that. Thank you.
Yeah. So it does not matter where your maximum element is present. Similarly, if Turtle wants to remove the minimum element, so it does not matter where the minimum element is present. He will always be able to remove the minimum element. If
Because
minimum
he
element is,
want to put the maximum. Yes, sir.
yeah.
Yes.
So if minimum element is present over here, so what he will do? He will choose this index and definitely this value will be greater than equals to this value. So this value will be
Yes, sir.
deleted since he is taking maximum of these two values.
Yes.
So it is always possible. Like,
Yes.
do anyone have
Sir,
any other doubt?
sir,
Yes.
I just want a confirmation that you will discuss question number 4 today.
Yes, I will.
Okay.
It's
Thank you.
actually mentioned in the discussion in the announcement section. Okay, no problem. Okay, anyone else? Any other doubt? No. So let's jump on to the code then. So code was a simple one. First of all, took the input shorted the array and just printed a value present at invite2. So this is all v is actually v dot begin comma v dot end. This is actually a temp. It is defined in my template. Okay. Anyone having doubt with this code? If the max is at first position and you want to remove the maximum element, am I right? You are telling max is at first position and I want to remove the maximum element. Yes. So what he will do? He will choose this as your AI. So AI plus 1 will be definitely lesser than this AI. And what he will do? What Piggy is doing? He is selecting the minimum of AI and AI plus 1. So minimum will be left out and maximum will be deleted. So this AI will be deleted. Right? If the maximum is present at the first position, that is 3, and the next element is 2. So Piggy will select the minimum of these two, which is 2. So he will keep 2 and delete 3. So the maximum will be deleted, right? Got it. Great. So let's jump on to the third question. Kindly mute yourself if anyone is unmuted. Okay. So this is the third question. So turtle and good pairs. It was actually a completely greedy question. I have some observations for it, but I don't have a complete proof as of now. So I will discuss the observations that I made during the contest and the solution that I submitted. Okay. So turtle gives you a string S consisting of lowercase Latin letters. Turtle consider a pair of integers I comma j to be pleasant pair if and only if there exists an integer k such that k is greater than equals to I, k is lesser than j, and both of the following two conditions hold. Sk is not equal to sk plus 1 and sk is not equals to si, or sk plus 1 is not equals to sj. Besides, turtle consider a pair of integers I comma j to be a good pair if and only if si is equals to sj or I comma j is a pleasant pair. So turtle wants to reorder the string S so that the maximum number of good pairs is maximized. Please help him. Okay. So first of all, let's understand the question. The question is that you are given a string S. So you have. Okay. So you are given a string S. So you have to form pairs. Okay. So this is I, this is J. You have to form pairs I comma J such that I is lesser than J. Okay. So looking at this, what are the possible pairs? This is a possible pair. This is a possible pair. There are multiple possible pairs possible, right? So there are many pairs possible and you need to check that whether those pairs are pleasant or not. Now, what do we mean by pleasant? So a pleasant pair is something like we can say that I comma j is pleasant if either of the two conditions are met. That is either s of I is equal to s of j, or you can select an integer k that is greater than equals to I and lesser than j such that sk should not be equal to sk plus 1 and sk is not equal to si, or sk plus 1 is not equals to sj. If we can find a k in between I and j, then if we can find a case that satisfies this condition between I and j, so we can definitely say that, okay, this pair I comma j is also pleasant, even if si is not equals to sj. Is the question clear? Is the question clear to everyone? Explain with example. Okay. So let's suppose I have, let me take, oh, let me take this EDDF. EDDF. So if I talk of these pairs, let's suppose I number them as 1, 2, 3, 4, 5. So what are the pairs? 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, next page. 2, 5, 3, 4, 3, 5, and 4, 5. These are the pairs we have. Okay. Let me tell you that whether these are pleasant or not. Can anyone say me, is pair 1, 2 pleasant? Is pair 1, 2 pleasant? No. This is because S of 1 is not equals to S of 2, first of all. And if they are not equal, then we need to find some k that is greater than equals to I and lesser than j, such that S of k should not be equal to S of k plus 1, first condition. The second condition is that Sk should not be equals to Si, or Sk plus 1 should not be equal to Sj. So if I am able to select some k like this, then I can say that, okay, even if Si is not equals to Sj, the pair is pleasant. In 1, 2, the only possible k I have is 1, because k should be greater than equals to I but lesser than j. Now j is 2 and I is 1. So the only possible k is 1. Now you can see that Sk is not equals to Sk plus 1. Okay, this condition is satisfied. But this condition is not satisfied because Sk is equals to Si and Sk plus 1 is equals to Sj. So we can say that, okay, this is not a pleasant pair. Do everyone agree with me that this is not a pleasant pair? The ones who are having the doubt in the question, do you all agree with me that this is not a pleasant pair? Similarly, talking of 1, 3, is this pleasant or not? So, okay, Si is not equals to Sj, not a problem. So let's find some k such that Sk is not equals to Sk plus 1. So if we select k is equals to 1, so we can see that, okay, Sk is E and Sk plus 1 is D. So Sk is not equals to Sk plus 1, agree. But these two conditions should also be met, that Sk should not be equals to Si or Sk plus 1 should not be equals to Sj. But over here Sk is equal to Si and Sk plus 1, which is equals to D, is equal to Sj. So okay, we can't select k equals to 1. So let's check for k equals to 2. So looking at k equals to 2, my Sk is D and Sk plus 1 is also equal to D. So I know I can't select this because Sk should not be equal to Sk plus 1. So I can't select k equals to 2. And when I do k equals to 3, so I can't select k equals to 3 because k must be lesser than j. So by the same logic, I can say that 1, 3 is also not a pleasant pair. So by this, you can check all other pairs and you can find out that what all pairs are pleasant or not. Is the conditions clear that when we are saying that whether the string is pleasant or not, whether a pair is pleasant or not? Okay. So now how to solve this? So some observations that I made was that, see, if I am keeping some alphabets together, so in this alphabets, first of all, the first observation is, let me not discuss this thing first. The first observation is that if I am keeping two distinct alphabets side by side, so I can never form this pair. Because I don't know k will satisfy this, isn't it? If I am keeping two distinct letters side by side, so I will never be able to form this pair. And if this is not so, if I am keeping some distinct letters, something like this, so I will always be able to form these pairs. If I have some numbers in between, like this E is not equals to D and we have greater than 1 numbers in between. So we will always be able to form these pairs. These pairs are always possible. The next thing that came to my mind was that, okay, we can't, if we are keeping distinct side by side, then we are reducing with one pair. One pair is getting reduced. So why not keep the same pairs together, same characters together? So in this, there is a problem. What is the problem? So the problem is that, let's suppose I have then E over here. So just observe one thing. I can never form these pairs. These pairs got eliminated. I can never form these pairs. Because Sk will always be equals to Si in these cases. I can never form these pairs. These pairs got eliminated. So leading to this, I came up to the conclusion, like there was a direct conclusion from here, that if there is a character coming 5 times, there is a character coming 3 times. If I sort them in descending order, there is a character coming 2 times, there is a character coming 1 time. So what I simply do is I print, first of all, let's suppose these are A, B, C, D. So what I do is I first of all print A, B, C, D. Okay. So this got printed 1, this got eliminated to 1, this got 2, and this got 4. Then again I printed A, B, C. So this got 0, this got 1, this got 3. Then I printed AB. This got 0 and this got 2. And then I printed 2 A's. This is something I did during my contest. And why I did something like this, that not 2 A's first and then A, B, C, D, A, B, C, A, B. Why I didn't print something like this? Because as already discussed, in these cases, I will never be able to form these pairs. Like these pairs are not possible. A to B, something like this. So what I decided is that, okay, I will keep the one that is having the maximum frequency. I will keep that at the end, and I will just print these, like try to keep the adjacent characters distinct as much as I can, so that I am able to print the maximum answer. I am repeating, I don't have the exact proof as of now, but this is something that I made during the contest by looking at the observation. And the observations were that, okay, when we are not keeping distinct, in that case, when the adjacent letters are distinct, in that case, only one pair is getting reduced, and we can form all other pairs with this particular. We can form all other pairs with this particular character. So we will sacrifice this pair and let's move on to some other pairs. Because while we were keeping all characters same, so this was the case. Like with this D, this E's were not possible. And this was the problem. Proof is why my approach is working. I made some observation, but I don't have any proof as of now. Why we can't have character 2 times? See, what I observed was that if I let's suppose have D, 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 E, 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 something like this. So just observe. Over here, I can't form these pairs. These pairs can't be formed. Because if you take D and E, you will never get a case as that Sk is not equals to Sk plus 1. And Sk is not equals to Sk plus 1. And if you select K over here, so Sk will be equals to Si. And Sk plus 1 will be equals to Sj. So either this condition will not be met, that Sk should not be to Sk plus 1, or this condition will not be met, that Sk is not equals to Si, or Sk plus 1 not equals to Sj. Yeah, you can make this, repeating only 2 times, but again, what's the logic? So if you want this, you want this. So again, over here, these pairs are also not possible, isn't it? So yeah, you all can look for some editorial solutions for this. I don't have much time, like I didn't have time to go to the editorial, but this is something that worked for me during the contest. Yeah, and the observations that I made was that I already explained. These were the observations I made. Yeah, so basically constructing different can make max pairs. Yeah, correct. Okay. So yeah, I know that. Really sorry, I am not able to explain the exact proof for this. I have to think a bit for the exact proof, but this is something that worked for me during the contest. Okay, so let's jump on to the solution. So you can code it down in any way you want. So this is something that how I coded down during the contest. So what I did is I first of all took input of length of string and the string itself, and for frequency of every character, I used a map and stored the frequency of each and every character. Then what I know that if there is a character coming 5 times, then there is a character coming 3 times, there is a character coming 2 times. So what I did was I simply first of all sorted them in descending order. Okay. Now I know that I have to print every character from here. Like let's suppose this is A, this is B, this is C, this is D. I am explaining the logic of the code that I have written. Okay, so there are multiple ways via which you can implement this. So first of all, I formed a string ABCD because every character is coming one time. Now to my answer, I simply pushed back ABCD. How many times? This many number of times, one number of times. What is the last character? And I maintained one variable sum, which is equal to 1. Now, once I'm done doing it for one time, ABCD, what I did was I came to C now. And I know that C has to come 2 times. But already I have taken it one time. So this sum variable tells me that how many times I have already taken it. So from my this string variable, if this is, let's suppose, temp, I simply pop back D because I know that I will not take character D anymore. And the number of times I have to take character C is nothing but one time only, because already I have taken it one time, which is reflected in my sum variable. So to my answer, I simply add ABC one time. And my sum gets incremented by 1. So my sum becomes 2 now. Now I come to B, and before coming to B, I pop back this C because I know that I have already taken C 2 times. I come to B now. So the value of B, the frequency of B is 3, but I have already taken it 2 times. So the number of times I have to take it more is 3 minus 2, that is 1. So I am writing this string AB once. And to my sum variable, I add 1. So my sum becomes 3. And I simply pop back B from this temp string. Now I come to this A. So the frequency of A is 5, but this sum variable is 3. This means that I have already taken A 3 times. So the number of times I need to take A more is 5 minus 3, that is 2. So I simply added this A twice. And I'm done with this. This is actually my final answer. So this is actually the logic of my code. So if I simply explain you all, so I constructed first of all the frequency by using map, and then I constructed a vector pair int comma character, that is storing the frequency for every character. So in my vector, I simply pushed back it.second comma it.first. So it.second is the frequency, it.first is the character. Then I shorted this vector and reversed this vector. So basically shorted the vector in descending order. So initially initialize my answer string to this empty string and temp to an empty string, and went to each and every character and push back that character to my temp string. So basically, first of all, I constructed this temp string, that is ABCD. I constructed this temporary string, that is ABCD. Once I have that string constructed, initialized my sum to 0 and started traversing from back. So initialized my I to v.size minus 1. Now, while I is greater than equals to 0, how many times do I need to print this temporary string? It is nothing but v of I dot first minus sum, as you all can see. That when I came over here, this value of sum was 2. So how many times I needed to print AB? It was nothing but v of I dot first, that is storing value 3. 3 minus the value of sum, that is 2, that is equal to 1. So required is v of I dot first minus sum. Now I went, so I need to add this temporary string required number of times to my answer. So simply ran a for loop for this and added this to my answer. Then I know that, okay, I added this value of required to my sum now. And from my temp, I simply pop back. That is, the current character will not come anymore. And I simply decremented my I. Once I done with this, I printed the answer. Debug is actually for debugging. You all can ignore these statements for now. That is actually for this. These are actually defined in my template, so you can ignore this for now. These are actually for checking the values and debugging the code. So there are multiple ways via which you can implement. Every time, like there is one more possible way. If I would like to say, there is one more possible way which I thought of during the contest was, initially the number of characters that you have taken is 0. Okay, so what you can do, you can go to for every time till the value of count is lesser than n. What you can do, you can traverse a for loop of I equals to 0, I lesser than 26, I plus plus. And every time you get a character that has a frequency greater than 0, you can simply add that character to your answer string and decrement the frequency of that character and increment your count. So till the value of count is lesser than n, that is you have not taken every character till now. You can do this and you can implement by that also. So there are multiple ways via which you can implement this. This is one possible way. Okay. Should we jump on to D1? What is the rating of this question? It may be around, like, I would say 1500, or like, if we go to exact proof, I don't know if it has some silly proof, or I am not getting it for now, but implementation wise, it was a basic 1500 or 1600 rated question. 1100 to 1200. Okay. Don't know then. Yeah, implementation wise, we can say that, okay, it was easy to think of something like this by looking at some observations. 1100, 1200. No, a bit more than that, I would say. 1400 is minimum, I would say. Rest, I don't know. I have not seen how many were able to solve this. You want to speak? Okay. Yeah, you are allowed, Tushar.
And sir, what is the rating for the B question, hypothetical?
B was an easier one. I would say like around 1000.
Okay, thank
Yeah. Okay. The rating of D1. D1 was around 1500 rated. I would say 1500. It was an easy one. Let me discuss D1 with you all, and you all will say that, okay, it was so easy. Give me a minute. I will have some water. Hmm. Okay. So let's start with D1. So the name of the question is Turtle and a Mix Problem, easy version. So one day Turtle was playing with n sequences. Let the length of the ith sequence with be Li. Then the ith sequence was AI1, AI2, AI, Li. Okay. Piggy gave Turtle a problem to solve when Turtle was playing. The statement of the problem was that there was a non-integer, non-negative integer x at first. Turtle would perform an arbitrary number of operation, possibly zero. Now this is something that I missed during while I was solving the question, and I was stuck like out of hell, like so many people were solving, but I was stuck over here because I ignored this, I overlooked this statement that possibly zero. So if you have an arbitrary number x from before, you can perform zero operations as well. We will see the significance of this as we move forward. Of operations on the integer. In each operation, what you would do is you will select an index I and set x to max of x comma ai1 ai2 ai1 ai li. So if let's suppose if in a sequence if there are li integers, so you can go to that particular sequence, take max with x, and and set the value of x to that. So Turtle was asked to find the answer, which was the maximum value of x after performing an arbitrary number of operations. So Turtle solved the above problem without difficulty, and he defined f of k as the answer to the above problem when the initial value of x was k. So first of all, let's understand the question till here, and then we will come to the rest of the part. So do you all understand what do we mean by mix? Do anyone have doubt with this, that what do we mean by mix? Mix of, I would say, 0, 1, 3, 7. What is the mix of this? Mix is 2. It is actually the smallest non-negative integer that is not present in the sequence. It is called as mix. Mix of 2, 6, 9 is 0. The smallest non-negative integer that is not present in the sequence is 0. This is actually what we mean by mixing. So the question is that you have to calculate f of k. Now what does f of k mean? F of k means that you initially have an integer k and you have n statements. So n statements is basically something like this. You have n sequences actually. So wait a minute. So you have basically n sequence, and these all sequences have some integers. So the length of the number of integers present in the sequence is given to you. So let's suppose the first sequence has 2 integers, the second one has 3, the third one has 1, and you are given the integers. Okay, you are given the integers. What you need to do is you can take this k. The operations that you can do is you can select this k, and you can select any of these sequences. Okay, you can select any of these sequences and take max of, if let's suppose this is a1, a2, a3, then you can do k is equals to max of k comma a1 comma a2 comma a3. With any of the sequences you can do something like this, and you can do it as many number of times as you want. The question is that fk tells you that what is the maximum value of k that you can obtain. So if I simply take an example over here, if I take one test case and explain you all with an example. So if let's suppose this is a test case, so you have 3 sequences. The first sequence has a length of 2. The numbers are 0 and 2. The second sequence has a length of 3 and the numbers are 2, 3, 3. And the third sequence has a length of 4 and the numbers are 7, 0, 1, 5. And I tell you to calculate the value of f of 2. That is, if you have the initial number as 2, then tell me what is the maximum value that you can obtain. So let's try what we can do. If we have value 2, okay. So if we are having value 2, so if you just take the max of this 2 with this particular sequence, what will be the value you will obtain? 3, isn't it? And I can see that I can't obtain a number greater than 3, so f of 2 will be 3. Let me take another number. Let me take for f of 1. Let's not 1. Let's take f of 0. Okay. For 0, what is the maximum number that we can obtain? So, first of all, which sequence you all are thinking to choose? Which sequence? Let me choose this particular sequence. Okay, sequence 1. So if I do max of 0, 0, 2, what will I obtain? If I do max of 0, 0, 2, what will I obtain? I will obtain 1. Now the value of k is 1. If I take k as 1 and take this sequence again, so max of 0, 1, 2 is 3, right? And you can try all possible combinations. You will never obtain a number that is greater than 3. So the maximum value of k that you can obtain if the initial value of k was 0 is 3. Similarly, the maximum value of k you can obtain when the initial value of k was 2 is also 3. Okay. So this is how actually the things are working. Now, what is the question? So now you all understand that what do we mean by f of k. So the question is that you are given m and you want to calculate f of 0 plus f of 1 plus f of 2 up till f of m. This is actually what question is. Is the question clear? Yes. So how we can do this? So there was a very basic observation. Just see one thing that just take the same sequence 0, 2. So length is 2, numbers are 0, 2. Then the length is 3 and numbers are 2, 3, 3. Length is 4, numbers are 7, 0, 1, 5. Right? Yes. Now just tell me one thing. If I tell you that, okay, I am using this sequence. Okay, I am using this sequence. Let's decode this particular sequence. The sequence is 0, 2. If I give you 1 over here, what is the max that you will obtain? If I give you 1 over here, what is the max that you will obtain? 3, right? And if I don't give you 1, I give you any other number, what will be the max you will obtain from this particular sequence? 1. Agree? So the max from this particular sequence is either 1 or 3, depending on the numbers that we are giving. Agree? Okay. Similarly, if we talk of this sequence, 2, 3, 3. If we are not giving 0 to it, if we are giving any other number greater than 0 to it, what will be the max value? 0. And if we give 0 to it, what will be the max value? It will be 1. Okay, clear, great. Decoding this particular sequence. If I give it any value other than 2, what will be the max value? 2. And if I give it 2, what will be the max value? It will be 3. So just observe one thing. I can never obtain a value greater than 3. By whatever operations I do, whatever my initial value is, I can never obtain a max value greater than 3. How will you obtain a max value greater than 3? It is not possible by using these sequences. And what I claim is that if the value that you are giving is lesser than equals to 3, the max value you can obtain is always 3. You can always obtain max value 3 by whatever value you give. Because just observe one thing. You can choose any sequence who are giving that max value 3. You can choose any sequence that are giving that max value 3. These two sequences were giving max value 3, right? So if you give it any number other than 1, you will get 1 from here. And once you have 1, you will be able to obtain that particular maximum max value, that is 3. Isn't it? If we have this sequence, if I give it any number other than 2, I will get 2. Once I get 2, I will be able to generate 3. So my claim is that if you have any number lesser than equals to 3, you will always be able to obtain a max value of 3. Do anyone have doubt in this? And if this is clear, then it is also very much clear that you will never be able to obtain a max value greater than 3, no matter whatever the number is. Agree? Agree? So the two observations was, the observation 1 was, first of all, you find maximum max value. Find maximum max value. The observation 1 was, for all k lesser than equals to max, we can always obtain final k equals to max. We can always obtain the final k value equals to max. And observation 2 was, for all k greater than max, we can never obtain final value, or let me not write it like this, for all k greater than max. The observation was that we can never obtain final value greater than max. So leading to this, what I decided was, for all numbers, what I want f of 0 plus f of 1 plus f of 2 plus up till f of m. So for all numbers that are greater than max, I will do 0 operations. For all numbers that are greater than max, I will do 0 operations because I want to maximize this value. So if let's suppose my max value is 3, and I want to calculate f of 0 plus f of 1 plus f of 2 plus f of 3 plus f of 4 plus f of 5. Let's suppose the value of m given to you was 5. Okay. So if the maximum max value possible is 3, so for all these, I can obtain value 3, final value 3. And for all these, I will do 0 operations and obtain value 4 and 5. So simply add them, and this will be my answer. What we will max it with 3, we will get max greater than 3. What is your question, Kushal? Can you unmute yourself and tell me? Yeah, array is 0, 1, 4, 2, 5. So if you have If you have 3, if you are giving any number greater than 3, in that case, the number will be 3. And if you have 3, the max value will be 6. So in that case, your maximum max will change to 6. Isn't it? Yes. So this was the logic behind this question. That looking at the values, we know that if we are giving it any value other than 1, if we are not giving it 1, we are giving it any value other than 1. So we will obtain 1. And once we obtain 1, we can obtain 3. And 3 is the maximum max value we can obtain via any of these operations. So yeah, I am able to obtain 3. If I am taking any number k lesser than equals to 3, or by any number, if I give you any number in the universe, I will be able to obtain the max value equals to 3. But why to push numbers that are greater than 3 into these? Because I can apply 0 operations as well. So what I will do for all the numbers that are greater than this maximum max value, I will not do any operation. I will tell that, okay, if you go into this thing that doing max and all, you will obtain a value which is lesser than what your current value is. So it's better that you don't go, stay here, do 0 operations and give me that value. And for all numbers that are lesser than equals to that maximum max value, I will tell them that okay, go inside, and from there I will get the maximum max value. So this is a simple logic to this question. Do everyone understand this? Should I jump onto the code? Yes. So the code is this. So took the inputs of n and m, set my final maximum max value to 0 and constructed one set. You will all get to know that. Do you all know how do we get the max value? Do you all know how do we get max values? By using sets, we can easily obtain max values, right? Like let's suppose you have integer 0, 1, 2, 4, 5, 6. So what you do? You simply push these values inside a set and simply traverse a for loop from 0. So you have 0 in the set, okay, no problem. You have 1 in your set, okay. You have 2 in your set, okay, but you don't have 3 in your set. So the max value of this array will become 3. This is how you obtain the max value. Now in this, we want a maximum max value. So how we will obtain the maximum max value? If we have the array 0, 1, 2, 4, 5, 6. So how will we obtain the maximum max value? So see, the first value that is not present, we will ignore that value and we will take the second value that is not present. Why? Because if we don't have this first value, we can obtain this first value. We can obtain 3. And once we have 3, we will be able to obtain 7. So we will ignore the first value that is not present and take the second value that is not present. And that will be my final maximum max. So initialize my maximum max to 0, constructed a set, and I am going to each and every sequence. So first of all, took the length of the sequence, and then for every length, I am taking the len number of integers. So while len minus minus, I am taking this integer and pushing that value or inserting that value in my set. So now initialize my y to 0, j to 0. So see, so while true, if st.find j is not equals to st.end, so I want to find the final max value. So initialize my j to 0. So I will keep on incrementing this j from 0 to 1 to 2 to 3 to 4, something like that. So if st.find j is equals to st.end, so I will check that is this the first value that is not found. So how I will check that? I have initialized my y to 0. So when I am getting this, I am checking if the value of y is still 0. This means that this is the first value from 0 that I have not found. So in that case, I will change my y to 1. But if the value of y is not 0, this means that this is not the first value that I have not found. This is actually the second value that I have not found. So in that case, I will change my final max value to max of the already one that I have and the value j. And I will simply break from here because I wanted to find the second value that I don't have. And if st.find j is not equals to st.end, so I am simply incrementing my j. Once I am done with this, so I know that I am done for this particular sequence. So I am simply clearing my set for the next set of sequences. After doing this, if the final value of max is greater than equal to actually what the value of m is, so my answer will be m plus 1 into var, because let's suppose the final max you obtain is 3 and the value of m is 2. So for f of 0 as well, for f of 1 as well, and for f of 2 as well, your answers will be 3. So how many times you are actually multiplying 3? M plus 1 time. So you see out m plus 1 into variable. If this is not the case, so what you do, if let's suppose the value of the final max value was 3 and the value of m was 5. So for f of 0, f of 1, f of 2 and f of 3, you know that the values will be 3. But for f of 4 and f of 5, you know for f of 4 the value will be 4 because you are doing 0 operations, and for f of 5 the value will be 5. So how many times you are actually multiplying var? You are multiplying var plus 1 number of times. Var was 3. The final max value was 3, so you are multiplying it 4 times. So var is getting multiplied by 4 times. So var into var plus 1. And then you need to find the sum of these values. How you can find this? Sum of m natural numbers minus sum of first m natural numbers minus sum of first var natural numbers. So you know the sum of first n natural numbers, the formula is m into m plus 1 by 2. So basically 5 into 5 plus 1 by 2 minus sum of first var natural numbers, that is 3 into 3 plus 1 by 2. If you do this, you will obtain, just a minute. If you do this, you will obtain this particular sum. So the same thing that I implemented over here. Var gets multiplied var plus 1 number of times, and then m into m plus 1 by 2 minus var into var plus 1 by 2, and then a new line. This was actually the logic and the code for this question. The doubt is, in your loop, if you break on the second time, then for 0, 1, 4, 5, wouldn't you get max as 3? 0, 1, 4, 5, 2, 3. No, yes, you will get, I will get max as 3 only. How for 0, 1, 4, 5 you are able to obtain 6? How for 0, 1, 4, 5 you are able to obtain 6? If you have array 0, 1, 4, 5, if you have 0, 1, 4, 5, so you give any value which is not equal to 2, then you will obtain 2. And once you obtain 2, you will be able to obtain 3. But how will you be able to obtain 6? Because once you get 3, you don't have 2 anymore. Once you get 3, you don't have 2 anymore. 2 was the value that you obtained, but you are not adding it to the sequence. Isn't it? Yeah. So from here you will return 3 only. That is the second value that you didn't find. Anyone else having any other doubt? Can you explain the last calculation part? Yes, I can. So see, if the value of m is greater than the value of var, so what you are doing? If let's suppose the value of m was 5, so you want f0, f1, f2, f3, f4, f5, isn't it? So if you are giving the values that are lesser than equals to 3, so you will always obtain the value 3 because the value of final max was 3. So how many times you obtain 3? Actually 4 number of times, for 0, for 1, for 2 and for 3. So var gets multiplied, var plus 1 number of times. Then you want this sum. So what is actually this sum is? So this sum is actually the sum of first 5 natural numbers minus the sum of first 3 natural numbers. Because if you have 1, 2, 3, 4, 5, you want this value. This value is actually what? So this sum minus this sum. So the the sum of first m natural numbers is m into m plus 1 by 2 minus the sum of first var natural numbers, that is first 3 natural numbers. So 3 into 3 plus 1 by 2. So the same thing I implemented here. M into m plus 1 by 2 minus var into m plus 1 by 2. Okay. Anyone else? Any other doubt? Okay. So that's all from today's PCD. Thank you for joining.